So let's talk a little bit about the difference between weather and climate and the composition of the atmosphere. It's usually joked that climate is what we expect and weather is what we get. And where that's true, that really doesn't tell the whole tale. Weather and climate are two really different things, scientifically speaking. They're both related to the current conditions or ongoing conditions in the atmosphere. But weather is over a very short period of time and is something that's constantly changing. So when we're talking about weather, we can talk about weather today, this afternoon. We can also talk about weather over a particular season, so this past spring or past winter. We can talk about weather over the course of a year. So on average, the weather this year was relatively hot, okay, because this year, 2016, was an El Nino year. Climate, on the other hand, is over a much longer period of time, and it's a generalized composite of the weather. So its averages taken from year to year and decade to decade over a long period of time, say 50 years or 100 years or even more than that. So when you're thinking about weather, you should be thinking about something that's short term, whereas when you're thinking about climate, you should be thinking about something that's average, that's normal for that time period. So let's pause for just a moment and start thinking about some things we can say about weather and some things we can say about climate. So let's come up with weather statements and some climate statements. Over here we'll put weather, like you have on your sheet, and over here we'll have climate. So one example of a weather statement would be, today it is raining. A climate statement would be, on average, Bumbletown gets 0.2 centimeters of rain in August. Notice that the climate statement is an average, whereas the weather statement is just one day. Now we can do something similar. So winter of 2015 to 2016 was very warm. Climate statement, on the other hand, would be, in most Watertown winters, we get a lot of snow. Notice that once again, these are statements, they're both kind of vague, but this one is talking about a particular winter, and this one is talking about winters in general. Now, if you'd like, you can post on your team boards under discussion questions for journals 1 and 2, some weather and climate statements if you want to practice this, because this is something that might show up on the test. I might ask you to compare a weather statement to a climate statement. So if you want to test your knowledge, go ahead and post those. But if someone posts, make sure, if you're a member of that team, respond to it. So what's the atmosphere actually made out of? The major components of the atmosphere are gases. The dominant gas is actually nitrogen. It makes up almost 80% of the atmosphere, about 78%. Now, I'm not going to test you, is it 78.2 or something like that. If you have a general idea that it's around 80%, you've got a good idea. Oxygen is about 21%. And then there's a mix in that remaining 1% of argon and other gases. Carbon dioxide only makes up about 0.038% of the atmosphere. So if we actually look at the composition of dry air, we see the majority of it is nitrogen. The second most common component of the atmosphere is oxygen. So that is the next largest proportion in volume. Then number 3 is actually argon, and after that, it's carbon dioxide. So the vast majority of the atmosphere is oxygen and nitrogen. We're talking about 99%. There are other important parts of the atmosphere. So water vapor can be up to 4% of the air's volume. Now, water vapor varies from location to location. So it can be close to 0% in the very driest areas of the world, such as the Atacama Desert and the McMurdo Dry Valleys in Antarctica. It can get to 4% in places like tropical ocean environments. So, for example, the Bahamas have a very high percent of water vapor in the air. That water vapor plays the important role of being a major portion of the water cycle, which we'll talk about later in this class. It forms clouds and precipitation and absorbs heat energy from the sun. Now, another important component are aerosols. Aerosols are little tiny pieces in the atmosphere, so small the tiny particulates actually float. Aerosols are important because without aerosols, we'd actually not have cloud formation. Now, some example aerosols include things like volcanic gases and particulates from volcanic eruption and volcanic dust, salts, small particles from sand from the blowing off of deserts. So those are some, pollen is a big one. So those are some of the sources of those really tiny particles. And those tiny particles actually stay suspended in the air due to Brownian motion. Now, some of the constituents of the air are very important, even if they don't make even if they aren't a large proportion of the atmosphere. One very important element of the atmosphere is the ozone layer. Ozone is very low levels, low concentrations here at the surface of the Earth. But up in the stratosphere, it's at relatively high concentrations. We're still only talking about a few hundred parts per million, but it plays the important role of protecting us from UV light. Now, ozone can be depleted by chlorofluorocarbons. However, we've actually stopped producing chlorofluorocarbons, and the ozone layer is actually now healing itself. So I hope you've enjoyed this introduction to the composition of the atmosphere and weather and climate. There's a lot more information in depth in your book, but this should give you a good place to start from. Some basic ideas that you should have gotten from this video: weather and climate are two different things. Weather is a short time period. It can be a single day, a single week, a year, a month, something like that. Whereas climate is a description of an average. So you can talk about the average monthly or the average temperature in August. That would be climate statement. Or average snowfall in winter. Another important idea is that the atmosphere is the majority of the atmosphere is actually made up of two gases, that is nitrogen and oxygen. Water vapor, which is also a gas, can make up a large proportion of the atmosphere's volume, particularly over areas that are very warm and have a large source of water, such as the tropical oceans. And finally, the ozone layer. Ozone is not a major volume constituent of the atmosphere, but it plays a role of protecting us from UV light from the sun. It can be destroyed by chlorofluorocarbons, But currently, because we have reduced our chlorofluorocarbons, CFC, production in the United States and all over the world from the Montreal Protocol, we are actually managing to heal the ozone layer over time. And scientists now predict that the ozone hole will be completely healed sometime around 2060 to 2070, so within most of your lifetimes.